I'm really excited to be. Can I do this? Oh, no. Okay. Whoops. Okay. Hello. So I'm really excited to share my experiences learning serverless with AWS. So my talk right now is called "With Great Scalability Comes Great Responsibility." Who here knows this reference? Do you guys know what it's from? Oh, not many of you. Okay. I'm disappointed. It's Wonder Woman. So originally when I proposed my talk, I thought I was going to make it Spider-Man themed, hence the title. But then I watched Wonder Woman, and so we're gonna go with, that was the best analogy that I could come up with. So I want you to imagine now for a moment that you are the queen of the Amazons. And then, so you have all of these Amazon warriors out in the cloud, and you want to make sure that they're all healthy, and you want to know if they're not healthy so that you can fix them, make them healthy. So this is sort of that's what my job is. I'm a performance engineer, and I'm trying to make sure that all of our services at my company are healthy, doing well. And so I do analysis on the performance data, I guess. Okay. So how did I get there? Just a really quick recap. I was working on the health of wind turbines, I guess. And then I started a women's chapter because I was lonely. And then I got into machine learning classification and ended up somehow analyzing the performance of software systems. So, okay, so let's start. So the data that I needed, we didn't actually own it. We had a vendor that it was a monitoring service. And so I wasn't able to just get started right away and start analyzing the data. I needed to get it first. And unfortunately, so we're just going to imagine that she's the oracle, the all-knowing, and I need to get something from her, some information. Well, unfortunately, I can't communicate directly with the oracle. I need to speak with her through Hermes, the messenger god, or an API, basically the API of our vendor. So now I'm going to kind of describe an ideal version of dealing with an API and the reality that I had to deal with. And I originally made this talk for Americans, and I recognized that in France, the ideal food you might have higher standards than this. So I made a quick edit, and I'm embarrassed to admit that was legitimately my first attempt at making croissants. It was like Pillsbury Doughboy, and I didn't realize you had to roll them up. I thought they just magically. Anyway, so our ideal version of working with the API. I could just ask Hermes, hey, Hermes, could you fetch me all the data that I want? He would go to the oracle and ask for all the data, and she'd give it to him, and then he'd give it all back. He'd say, here's your data. Now, in reality, it wasn't that nice. I'm going to walk through the process. I'd say, hey, fetch me all of my Amazon warrior troops, please, which are groups of these Amazon services. And he would go and ask for that and give me back, okay, here are these troops. And then I would have to say, okay, for troop 1, will you please fetch me the Amazon warriors, which would be the services, the names of the services, of the specific ones. So he'd give me those back, and then I would have to say, okay, so for Amazon Warrior 1, could you please get me the data groups? So I'm still not getting the data. I'm getting a group of types of data. So he goes and asks the oracle and gives back the groups. And then finally, I say, okay, for Amazon Warrior 1 and data group 1, could you please fetch me the data? And then I finally am able to get the data that I'm looking for. And so it ended up being a bigger process than I expected. In my case, it was like 35 to 65,000 API calls just to get like one set of data for a certain time period. Quick, just gonna. So I had to ask myself, how should I write the code to communicate with Hermes? And that's kind of what my talk is about, is building this data pipeline, figuring this out. So first, I tried to just do multiprocessing with Python because I was comfortable with that, and I put it in an EC2 instance. It was not cheap, though. It was like $700 a month, and I just felt like dealing with horizontal scaling would be kind of too much work. I was trying to do this as quickly as possible so I could just get to the analysis. And I didn't want to deal with having to maintain like ongoing maintenance. So the next kind of iteration was to run it intermittently. That saved a bunch of money. Obviously, just to only if it's a batch process, just like only run it when you are actually using it instead of 24 hours. But I still had the other issues. So I tried out spot instances before I came to serverless, and I guess it turned out spot instances aren't great for long-running processes. I would have to figure out a way to save the state or make sure that I don't restart the whole process every time that I lose the instance because of if my bid goes down too low. So finally, I asked myself, okay, maybe I should try this cool thing, serverless, and then I don't have to maintain it. And my impression of it at the time, and this is the way I understand it, is like we're not the first industry to go through this process of where we used to all have family cars and we'd have to deal with the maintenance of it, and we're moving towards this like shared model where it's more convenient. You pay by the minute for these car to goes. I don't know if you have I think you have a car sharing thing in France, but I don't know which one it is. So this was sort of. So I finally moved. My first attempt was I had heard about step functions. Okay, so the basic unit Lambda, I'm like, okay, I get that. It has like a certain limit of memory and compute, and I can only run the process for up to 5 minutes. I'm cool with that. And then I learned, okay, actually, so it's running in a Linux environment, and when I was testing my code, I was testing it in a Mac environment. So it was like very quickly I learned, okay, I should use a Docker container to test my code in a Linux environment, so that I'm not I don't keep deploying it and it works locally, but it doesn't work in the Lambda. And then along those lines, the dependencies. So I was using Python, but I relied on external dependencies like the requests library. And this limit, 250 megabytes per, for uncompressed code, seems really reasonable. But it turns out if you, I wanted to convert the data into Parquet. It's like a file format that makes it more compressed. And the library that you use is called Fast Parquet, and it's too big. It doesn't fit in a Lambda. So that was something I ran into. Another concern that I eventually ran into was that I was sharing an account with everyone at my company. We have one account for production and one account for development. And if I was trying to run so many Lambdas concurrently, it kind of ate away at the pool of 1,000 concurrent in the entire account. So, okay, the next question I had was, I get it, I made this Lambda, but I want multiple Lambdas doing multiple things, and I want them to communicate with each other. So how do I orchestrate them? And that was where I found step functions, which is, here's a simple example where you run the blue Lambda, and then the output gets sent to the red Lambda. The red Lambda runs and sends the output to the yellow Lambda. You can define with step functions other different things like a choice state. So in this case, the blue Lambda will do something. Depending on what it returns, it'll either run the red Lambda or it will run the yellow Lambda. And this is what I got excited about, because I was doing multiprocessing in Python, and I said, I could do parallel processing with step functions. So you could run the blue Lambda and then run the red Lambda at the same time as the yellow Lambda. But I wanted to do like sort of this dynamic fan-out parallel processing in the sense that the blue Lambda would ask Hermes for the Amazon warrior troops, and then I would get back a list of troops, and I don't know exactly what the size of the list is, and for every item in that list, I want to spawn a Lambda to do the next step, to ask for the Amazon warriors. And I wasn't able to do that with step functions. I wasn't able to define a dynamic response. So this was kind of my first attempt with serverless. It fell short a little bit. So there are ways that I could account for, like I could have stuck with step functions. I kind of knew that generally speaking, we had, in my use case, I had 300 Amazon warrior troops. And so I could have said, okay, yeah, just run 6 concurrently. And I could have just defined, like, the other thing I could have done is sent the output to an EC2 instance, but then I'm back at the first problem that I had, which is I didn't want to maintain an EC2 instance. So my conclusion was that, okay, it's easy to implement a workflow with Lambdas and EC2 instances, and it has this cool, like, built-in back-off policy if I need to retry my Lambdas, but it didn't work for me because it didn't yet support this dynamic fan-out parallel processing. Okay, so then I moved on to event triggers with S3. So this is an S3 bucket that stores things, objects, and I kind of treated it like a file system. So I have these leading keys, troops, Amazon warriors, data groups, data. So that all that means is if I put an object in there and it starts with troops, it's essentially like in the troops folder. You can think of it that way, that they all start with this leading key troops. And then there would be, so my first Lambda would ask for the Amazon warrior troops, and then for each troop, it would send it would create a file in the S3 bucket with the leading key troops. Okay, so then each file would have an event trigger, and it would trigger a Lambda, and it would give like the file name to this new Lambda, and that Lambda would go and ask for the Amazon warriors for that particular troop. And then the red Lambda is going to do the same thing. It's going to get back a list of Amazon warriors, and it's going to write a file for each warrior under the leading key Amazon warriors. And then, oh, sorry, I had a small detail. So I was doing this with CloudFormation, and I got so frustrated because this setup ended up having a circular dependency, and I thought, I should be able to do this. This shouldn't be a circular dependency. So my workaround was to just hard code in the name of the bucket. And then it was sort of like, it would allow the CloudFormation to work. It would kind of like hide the fact that there was a circular dependency. You could also deploy the bucket in a different stack, and then already have the bucket, and then reference the bucket in your like new stack. So, okay, so the same thing happens. So there's like a file for every warrior, and these trigger then the yellow Lambdas, which go and get the data groups. And then once again, those will send all of the data groups like as an individual file to this leading key data groups, which will trigger the next set of Lambdas. And when I finally got this working, I was really excited. I felt like this moment, oh, let's see, does it start? Like this in Wonder Woman is like she didn't know she was a god, and then she realizes like, wow, I'm really powerful. And so that was sort of like my experience. I got really excited to run this. I mean, I just want you to appreciate, I know it like took a while for me to get through it, but like just really quickly, let's run through again. Like first, like each file triggers the red Lambdas, and then there's extra files that get written which trigger the yellow Lambdas, and then those create files which trigger the orange Lambdas. So this is like all happening at the same time, which ended up being too fast. It actually took down our vendor's service for an hour. Yeah, so I was like actually really sad because I took a while for me to figure out this architecture and get it working. And then our vendor responded like the next day, and they said like, oh, you have a rate limit now. So now I had to figure out, okay, I thought this was really cool, it was really scalable, but now how do I make it like scalable but also have rate limits? Oh, yeah, so, whoops, this was my conclusion, sorry. Oops, oh, she's gonna do it again. She's gonna come in slowly. Okay. So yeah, this was like my conclusions from the second iteration, was that S3 is really cool, it's highly scalable and durable, and if you do these nested event triggers, you can create really fast multiprocessing, but you can't, with event triggers, you can't control the rate that these Lambdas get kicked off on, because they just happen, they get triggered as soon as the event happens. And if it fails, like for instance, when I took down the vendor's service, the Lambda will just like retry right away. So then all of a sudden I had like all these extra calls because it retried twice, and then it stops retrying and it doesn't get sent anywhere. I would have to build something to handle, okay, so that I didn't lose these tasks that I wanted to get done. Otherwise, it would just try twice and then give up, and I wouldn't even know that it didn't work. So yeah, you can basically lose in-flight tasks with this system, like if you're not tracking. So yeah, I guess like I was just like kind of like, wow, I had to sit back and be like, oh my god, like if you hadn't architected to be scalable, then you wouldn't have ever had this problem, which brought me to this like next final version that worked, which was to rate limit with queues and CloudWatch rules, triggered Lambdas. Okay, so let's go through SQS queues. So the Lambda is a consumer. It grabs an item off of the queue, and I have this little clock there to show that this invisibility timeout starts, which is, I think the default is 30 seconds, but you can define it. You can say, I think this Lambda should only take this long to process it. If it takes longer, then please just put the item back on the queue, make it visible again. So the item doesn't actually leave the queue when the Lambda grabs it off of the queue. It sort of becomes invisible to other consumers. So it successfully processes the task, and then the Lambda has to actively, like itself, delete the item from the queue. Then it moves on and grabs the next item. So here's a failed task. It grabs it, it fails, and then it just doesn't write it off of the queue. It stays on the queue for the next Lambda to try to process it. Another possibility is if the task times out with the invisibility thing. So this Lambda is just really slow, it's taking forever, and finally the timeout, it hits the timeout, and it just says, okay, that's cool, you took too long, I'm going to become visible to other consumers. And this is a problem, because then you could have duplicate work. So in my case, it's totally fine if I if I make the same API call twice, because I'll just overwrite a file. But if you're dealing with like money transactions, you don't want to have duplicate, like you don't want to have something for a task from the queue being duplicated. Oh yeah, I don't know. I guess I thought of this whole process as like sort of like dating, I guess. But in the sense that you like, I don't know, don't have to explain that, but in the sense that you like, the person doesn't become, they become invisible to other people, and you figure out if you want to process, and then otherwise, and then they go back on the queue if it was unsuccessful. Anyway, okay, but the Lambda can actually grab 10 items at a time and do this whole process, so it's like a kind of weird form of dating, I guess. So yeah, just like running through really quickly, it processes these successfully, it fails one, it leaves it on the queue, and then it fails another, and then these two end up timed out so that another Lambda grabs them, and then there's duplicate work. So that's just something to kind of consider how that would work. Oops. Okay, now on to CloudWatch rules. So CloudWatch rules are basically, it's like a cron job. It's a schedule, and you say, run this Lambda on this schedule. So every minute, every hour, at 8 o'clock every morning. And this is, the basic architecture that I came up with. So the first one, I wonder, do I have like I do, a little laser. Okay, so the first one runs, kicks off the Lambda, and then instead of writing it to the S3, like writing a file to S3, it writes a task to an item to this queue for every troop. And then this second Lambda grabs 10 at a time, tasks from this queue, and then goes and asks for the warriors for each of those troops, and then sends it to this queue. And this one just keeps asking for 10 and processing until the 5 minutes is up. So it just runs throughout the whole 5 minutes. And then eventually it gets to S3, and it ends up going just into there. So I did figure out a way to make use of those event triggers that were really fast. Basically, if you're communicating with an external source, like an API that you don't own, you need to rate limit. But I wanted to just process the data, like clean it a little bit, and then put it in a different format back in S3. So that was like a great use case for triggers, for S3 event triggers, because as soon as I dropped the raw data in, it would trigger Lambda to clean it up and then put it in a different like leading key, in a different like folder. Okay, so then I was I had it, like a working solution. I was really happy with it, and I kind of started to look at the data of like, how is it working? Is there a way I can make this better? And the first thing I noticed was this so this is like how many tasks are in the queue over time, and so it kind of jumps up. The last queue ends up with a ton of tasks because this is like there's like over 22,000 tasks in the last queue. The other two queues are like much smaller. In terms of like data groups, there's only Amazon warrior troops, there's like 300. Okay, so this like tail here is what I noticed, that basically after 4 p.m. it seems like everything's been processed, but there's some that have failed that are sticking on the queue. That the queue is just keeping these tests, and they just keep failing, but they don't ever leave the queue. So I thought, let's clean that up. So luckily there's a service for that. You can connect a dead letter queue to your queue, and you can define how many times you want to try this task before you send it to the dead letter queue. So you can say, hey, let a Lambda, let this item, this task be tried 5 times, and then I just want it to go to the dead letter queue. And what's really nice about that is it filters it out. Then I can look at the dead letter queue and I can evaluate, oh, okay, this is failing because of this, and it's not like clogging up my original queue. Okay, so what's the next thing that I noticed from this? The next thing, there's like all this time. Oh my God, sorry. There's all this time where nothing's running, like where nothing is happening. There's no processing. But the way I had it set up, I was running each of my Lambdas on a schedule every 5 minutes, and they were running for 5 minutes. So I was paying for all this time that I wasn't doing anything. So basically I solved this with like 2 lines of code. This is the basic, like, okay, grab 10 items off the queue. If it doesn't work, then don't delete it, essentially. Then you don't end up deleting it off the queue. So yeah, here's the Lambda. It's kind of just like a continuous process that's running 24/7. So then I add this, I guess it's 3 lines. I say, hey, if there's no messages on the queue, then just leave. Like, you don't have to do your work. You can go home. And then, so it looks like this. A Lambda still gets triggered every 5 minutes, but it only runs for a short amount of time. So I pay for the invocation, and I pay for like the small amount of time that it runs. But this went from $7 a day to less than $1 a day for this whole process. Okay, so this is just a bonus add-on. Is like, oh, what about SNS topics? Like, would that be useful? And SNS topics are like, oh, but a bunch of different queues can subscribe to an SNS topic. So this is like the next level up is I could add SNS topics. I could have the Lambda send it to an SNS topic, And then this queue is subscribed to it, and it'll get the items, and just kind of put these here. Well, why would you do that? It seems like you're just like adding this extra step in the pipeline. That doesn't make sense. What's good about it is that now, let's say that I later down the road figure out that after this API call, I have some other process that I want to do to the Amazon Warrior troops. So then it's really easy for me to just subscribe a new queue to this SNS topic. And I don't have to edit the code inside the Lambda. So it just is like it helps you decouple. Because basically before in the Lambda, I was saying, hey, send it to this queue. So I had that code in there, and I would have to go in there and add another, like, hey, send this to this queue, to like Q2. Okay. So SQS queues are highly scalable and resilient. They can store failed tasks indefinitely, which is really great. So if there's like a system outage or something, you still have your tasks there waiting to be processed. And it gives you control to rate limit. So one thing to consider with this is if you have, it's kind of like going to the grocery store and there's people in front of you that have a lot of groceries and you just want to buy one thing, and you're kind of just stuck in this line. So you could have a small task that gets put on a queue and it's just waiting in line with a bunch of other tasks or other really big tasks that take a lot of processing. CloudWatch rules allow for like pretty specific schedules. It only goes up to 1 minute though. And what I didn't like about the CloudWatch triggered is that basically I did this trade-off where I was too scalable, I needed a rate limit, and so I completely switched to rate limiting and not being scalable at all. Like this final solution, it works, but it's not responding at all to how many items are in the queue, which would be nice if I could have both. Like, can I have it be scalable and can it rate limit? So these are kind of my general takeaways. Just kind of like wrap up with reminders. Lambdas are like not yet suitable for quick tests if they require large dependencies, like that fast parquet example. So I was originally really excited that I could use serverless to do some data science things, but it's not really. A lot of the data science packages in Python are really big. They wouldn't fit in a Lambda. And yeah, unfortunately, step functions doesn't allow a dynamic fan out for parallel processing. And then this was like a point that was true for me when I was building this, that event triggers don't yet allow you to rate limit. But now, after reInvent 2018, you can actually specify a threshold for a specific Lambda. So it does eat away from your 1,000 limit invocations in your account. But you could say, this Lambda can only run up to 200 times. That still wouldn't have been like the quick fix to my S3 triggered events, because I still would have had to figure out how to add dead letter queues or some way to handle failed attempts. Okay, right. So you can't yet trigger a Lambda based off the queue depth, which would be really nice if I could say, hey, because you can do auto scaling with EC2 instances. So I would like to be able to say, oh, wow, there's more stuff on the queue, like spin up some more Lambdas, but then still have a rate limit. And SNS topics are a great way to decouple your code so that you don't have to refactor your Lambda code. You can just add queues to subscribe to the topic. And then sort of like a final kind of reflection was, for me, this was a really long process, and I could have been faster if I had broken it up more. And I was new to the company, and we had multiple we had different build deploy pipelines. And so first I had to pick which one I was and it felt like I was choosing teams or something. And I was learning this particular build deploy pipeline that was custom to this company at the same time that I was trying to learn serverless architecture. And that felt really overwhelming, and it was really frustrating. Iterating was really slow. So if I could go back, I would say, first, just like learn your company-specific build deploy pipeline really well, understand how that works, and then move on to like experimenting with more complicated serverless architectures. And so finally, my message is that with great scalability comes great responsibility. And I hope that you guys have fun, not dangerously, with serverless. Thank you.